Imagine two planets, hurtling through space at incredible speeds, suddenly locked on a catastrophic collision course. The idea seems like something from science fiction, but planetary collisions are very real, and they've shaped not just our solar system but potentially countless others across the galaxy. But what exactly happens when two planets collide? Is it an explosion beyond comprehension? Does it cause total destruction, or can such events lead to new celestial bodies forming from the chaos? In today's exploration, we will dive deep into this fascinating phenomenon. From the violent history of planetary impacts in the early solar system, to modern-day predictions of potential collisions, we will cover the mechanics, the aftermath, and the profound consequences of these events. We'll discuss how these impacts have shaped the very structure of our solar system and why they remain a possibility in the vast, ever-changing expanse of the universe. This is the ultimate cosmic clash, a story of destruction and creation on the grandest of scales. Let's begin. The early chaos of planet formation. To truly understand the mechanics and aftermath of planetary collisions, we need to go back to the very beginning, roughly 4.6 billion years ago, when the solar system was still in its infancy. In these early days, there were no well-ordered planets in neat orbits around the Sun. Instead, the solar system was a chaotic cloud of gas, dust, and rock particles. Over millions of years, these materials collided, stuck together, and grew, eventually forming larger and larger bodies known as planetesimals. These planetesimals were the building blocks of planets. However, the process of planetary formation wasn't peaceful, it was violent, turbulent, and destructive. These early collisions were essential for growth, as smaller bodies merged to form larger ones. But not all collisions were constructive. Some impacts were so violent that they shattered planets, sending debris flying across space. One of the most significant and well-known planetary collisions occurred between Earth and a Mars-sized object scientists have named Theia. This impact, which took place around 4.5 billion years ago, is thought to have been responsible for the formation of Earth's moon. The collision was so catastrophic that it ejected a massive amount of material into orbit around Earth, which eventually coalesced to form the moon. In addition to giving us our moon, the collision also had other profound effects. It tilted Earth's axis, giving us seasons. The giant impact hypothesis, which explains the moon's formation, is one of the most well-known examples of planetary collisions. But it's not unique. Similar events occurred throughout the solar system in its early years. Mercury, Venus, Mars, and even the gas giants all show signs of having been shaped by massive impacts. The early solar system was essentially a battlefield, with young planets colliding, merging, and sometimes being destroyed. Even the unique tilt of Uranus, which rotates almost entirely on its side, is believed to have been caused by a massive collision with an Earth-sized object billions of years ago. These collisions didn't just shape individual planets, they helped determine the entire layout and structure of the solar system as we know it today. But why were collisions so common in the early solar system? The answer lies in the chaotic nature of planetary formation. In those early days, there were no stable orbits. Young planets moved erratically, pulled by the gravity of other bodies, leading to frequent collisions. Over time, as planets grew larger and their orbits stabilized, the frequency of collisions decreased. However, these early impacts played a critical role in shaping the solar system's final architecture. The science of planetary collisions. What exactly happens when two planets collide? The forces involved in such an event are beyond anything we can truly comprehend. Planets are enormous objects, and they travel through space at incredible speeds. For example, Earth moves around the Sun at about 30 kilometers per second, or roughly 67,000 miles per hour. When two planets collide at those speeds, the amount of energy released is almost impossible to imagine. Let's break it down in simpler terms. A collision between two planets would release kinetic energy, essentially, the energy of motion. When this energy is converted upon impact, it generates heat, light, and shockwaves that can be felt across vast distances. The force is so great that it would vaporize the surface layers of both planets, turning solid rock into molten lava and superheated gas. In the initial stages of the collision, the gravitational forces between the two planets would start pulling them apart. Before the planets even touch, their atmospheres would collide, generating shockwaves that would cause massive disruptions in the skies. As the surfaces meet, the kinetic energy would cause the planets to deform, their crusts breaking apart in the process. If the collision is head-on, the results are nothing short of catastrophic. The sheer energy involved would likely obliterate both planets, reducing them to clouds of debris. This debris would be scattered throughout space, potentially forming new moons or even a ring system around the surviving fragments. In cases where the collision is less direct, a glancing blow, for example, one planet might survive relatively intact, absorbing much of the smaller planet's mass. The angle at which the planets collide is critical in determining the outcome. A head-on collision between two similarly sized planets would likely result in the destruction of both. However, if one planet is significantly larger than the other, the smaller planet might be absorbed into the larger one. In this scenario, the larger planet would survive, but it would be significantly altered by the impact. Its surface would be reshaped, its atmosphere disrupted, and its orbit potentially changed. One of the most fascinating aspects of planetary collisions is their potential to create new celestial bodies. For example, the debris from such a collision could eventually coalesce to form new moons, much like how Earth's moon is thought to have formed. In some cases, the debris might form a ring system, like the one we see around Saturn. These rings could persist for millions or even billions of years, a lasting reminder of the violent event that created them. Real-life evidence of planetary collisions. While we haven't witnessed a planetary collision in modern times, there is plenty of evidence to suggest that these events have occurred in the past. One of the most compelling pieces of evidence comes from the study of craters on planets and moons throughout the solar system. These craters, some of which are hundreds or even thousands of kilometers in diameter, are the remnants of massive impacts. Take, for example, the Moon. The surface of the Moon is covered in craters, many of which were created by impacts during the early days of the solar system. Some of these craters are so large that they suggest the objects that created them were comparable in size to small planets or moons. These impacts didn't just leave scars on the lunar surface, they played a role in shaping the Moon's geological history. Another example comes from Mars. The surface of Mars features an enormous impact basin known as the Hellas Planetae, which is about 2,300 kilometers, 1,400 miles, in diameter. This basin was likely created by the impact of a massive asteroid or planetesimal during the early solar system. The Hellas impact may have had a profound effect on the climate and geology of Mars, potentially contributing to the planet's transition from a warm, wet world to the cold, dry planet we see today. But the evidence of planetary collisions isn't limited to our solar system. In 2008, astronomers discovered an intriguing star system known as BD plus 20307, located about 300 light-years from Earth. Observations revealed an unusual amount of dust surrounding the star, far more than would be expected in a stable planetary system. The best explanation: two Earth-sized planets had collided, creating a massive cloud of debris that was still observable even millions of years after the event. This discovery was groundbreaking because it provided direct evidence that planetary collisions are not just relics of the past, they are still happening in other parts of the galaxy today. It's a stark reminder that our solar system, while relatively stable now, was once a much more chaotic place. The aftermath of planetary collisions. The aftermath of a planetary collision can vary widely depending on the size, speed, and angle of the impact. In some cases, the result is total destruction, with both planets reduced to clouds of debris. In other cases, one planet may survive, but its surface, atmosphere, and orbit are drastically altered. When two planets collide, the most immediate consequence is the release of a tremendous amount of heat. This heat is so intense that it can vaporize large portions of both planets' crusts, turning solid rock into molten lava and superheated gas. The impact also generates shockwaves that travel through the planets, shattering them from within. If the collision is especially violent, the planets may be completely destroyed, leaving behind nothing but a cloud of debris. Over time, this debris could coalesce into new celestial bodies, such as moons or ring systems. In some cases, the debris might form an asteroid belt, similar to the one that exists between Mars and Jupiter. This belt, known as the asteroid belt, is thought to be the remnants of a planet that was destroyed by a massive collision billions of years ago. However, not all collisions result in total destruction. In some cases, one planet may survive, but it is forever changed by the impact. The planet's surface may be scarred by massive craters, and its atmosphere may be disrupted, leading to dramatic changes in climate. The planet's orbit may also be altered, potentially bringing it closer to or farther from its parent star. One of the most intriguing possibilities is the creation of moons from the debris of a planetary collision. This is exactly what scientists believe happened in the case of Earth and Theia. But Earth's moon is not the only example. Many of the moons in our solar system, particularly those around the gas giants like Jupiter and Saturn, may have formed from the debris of massive collisions. In addition to creating moons, planetary collisions can also give rise to ring systems. Saturn's iconic rings, for example, may have been formed by the debris of a moon that was shattered by a collision. These rings are composed of countless small particles of ice and rock, which are thought to be the remnants of a larger object that was torn apart by Saturn's gravity or destroyed in a collision. Could Earth be at risk of a planetary collision? The idea of Earth being involved in a planetary collision is both fascinating and terrifying. While the likelihood of such an event happening in the near future is extremely low, it's not entirely impossible. In fact, scientists have identified several potential scenarios in which Earth could be at risk of a collision. One of the most well-known threats to Earth comes not from other planets but from asteroids and comets. While these objects are much smaller than planets, a collision with a large asteroid could still have catastrophic consequences. The impact of an asteroid just 10 kilometers in diameter is believed to have caused the extinction of the dinosaurs 66 million years ago. This impact, known as the Chicxulub impact, released energy equivalent to billions of atomic bombs, creating a cloud of dust and debris that blocked out the sun and caused a dramatic cooling of the planet. While asteroid impacts are more likely than planetary collisions, there is still a very small chance that Earth could one day collide with another planet. One potential scenario involves Mars's moon Phobos, which is slowly spiraling closer to the planet. In about 50 million years, Phobos is expected to either crash into Mars or be torn apart by tidal forces, forming a ring around the planet. While this event won't directly affect Earth, it serves as a reminder that planetary collisions are still possible in our solar system. Another, more remote possibility involves rogue planets, planets that have been ejected from their home systems and now drift through space. If a rogue planet were to enter our solar system, it could potentially disrupt the orbits of the planets, leading to a collision. Fortunately, there is no evidence to suggest that any rogue planets are on a collision course with Earth, but the possibility remains. In addition to rogue planets, there is also the long-term possibility of planetary collisions caused by the eventual death of our Sun. In about 5 billion years, the Sun will enter its red giant phase, expanding to engulf Mercury, Venus, and possibly even Earth. As the Sun expands, the outer planets may be thrown into chaotic orbits, increasing the chances of collisions between them. While these scenarios are incredibly unlikely in the near future, they serve as a reminder that the universe is a dynamic, ever-changing place, and planetary collisions are just one of the many forces shaping the cosmos. The role of planetary collisions in the evolution of life. While planetary collisions are often associated with destruction, they can also play a role in the creation and evolution of life. In fact, some scientists believe that life on Earth may owe its existence to a series of planetary collisions and impacts. One theory, known as panspermia, suggests that life on Earth may have been seeded by materials delivered during collisions with comets or asteroids. These celestial objects could have carried water and organic molecules, the building blocks of life, to the early Earth, creating the conditions necessary for life to emerge. In addition to delivering the ingredients for life, collisions can also create the right environmental conditions for life to thrive. For example, the collision between Earth and Theia not only gave us the Moon, but it also helped stabilize Earth's rotation. This stability has played a crucial role in creating a climate that allows life to flourish. But planetary collisions can also wipe out life on a massive scale. The Chicxulub impact, which caused the extinction of the dinosaurs, is a prime example of how a relatively small collision can have a profound effect on life on Earth. If a planet-sized object were to collide with Earth today, the consequences would be far more severe, likely wiping out all forms of life and rendering the planet uninhabitable. Predicting and preventing planetary collisions. While we can't prevent a planetary collision from happening in another star system, scientists are working hard to ensure that we can detect and potentially prevent such events from happening here on Earth. NASA's Near-Earth Object Observations program is constantly scanning the skies for asteroids and comets that could pose a threat to Earth. By tracking the orbits of these objects, scientists can predict whether any of them are on a collision course with our planet. While this program is primarily focused on smaller objects like asteroids, the same technology could be used to track larger objects, such as rogue planets. In addition to tracking potential threats, scientists are also exploring ways to prevent a collision from happening. One proposed solution is to use a technique known as the gravity tractor. This involves sending a spacecraft to a near-Earth object and using the gravitational pull of the spacecraft to slowly alter the object's orbit, steering it away from Earth. While this method has not yet been tested on a real threat, it shows promise as a potential way to prevent a collision. Of course, if we were ever faced with the possibility of a planetary collision, the best course of action would likely depend on the size and speed of the object involved. In some cases, it might be possible to divert the object before it reaches Earth. In others, evacuation of the planet might be the only option. The future of planetary collisions. As we look to the future, it's clear that planetary collisions will continue to play a role in shaping the universe. While the chances of a collision happening in our solar system are relatively low, the same cannot be said for other parts of the galaxy. In young star systems, where planets are still forming, collisions are likely happening on a regular basis. In the distant future, when our Sun enters its red giant phase and begins to expand, the inner solar system may become destabilized, increasing the chances of collisions between the remaining planets. As the Sun engulfs Mercury, Venus, and possibly even Earth, the outer planets may be thrown into chaotic orbits, potentially leading to new collisions. One thing is certain: planetary collisions are an integral part of the universe's evolution. They have shaped the planets we see today and will continue to do so for billions of years to come. So, what happens when planets collide? The answer is a mix of destruction and creation. These collisions can obliterate worlds, give birth to new moons and planets, and even play a role in the evolution of life. While the chances of Earth experiencing such a collision are slim, the possibility remains, reminding us of the dynamic and ever-changing nature of the universe. Thank you for joining us on this journey through the cosmos. If you enjoyed this video, be sure to like, subscribe, and hit the notification bell for more mind-blowing content about space and the mysteries of the universe. Until next time, stay curious and keep exploring.